we go. So finish 5.3 and do 5.4. All right, so we're moving on to graphing exponentials. I think I barely began that at the end of class, right? So let me write it again. Here's the general look. It is a plus c times b to the x. So we're adding to our toolbox. Remember our 6 basic memorized graphs and how we graph them, right? The absolute value v and the x squared, the square root, and the x cubed, and the cube root, and the 1 over x with the 2 branches, right? Remember those basic 6? Now we're going to add to that exponential, and we're also going to add logarithm, both today. Exponential and log. What does a basic exponential graph look like? What does a basic logarithm graph look like? Okay, well, here's what it looks like. The first thing you need to know is A is an asymptote line. Asymptote line. So that's a line of asymptote. What does that mean on the graph? It's horizontal because what are they called? Exponential graphs always have a horizontal asymptote. So that would be horizontal asymptote at A. So whatever that number is, in this case it's the 5, you see. The number added or subtracted without an x on it, that's going to be the asymptote. So like on this graph, the first thing I'm going to do when we go to graph that in a second is I'm going to go horizontal asymptote up at positive 5. That's what you start with, is that horizontal asymptote. Then from there, just go ahead and make the xy table and do find the center point and one other point like we always do. All right. So let's give it a try. So coming over here, you look at that equation right away and you go, oh yeah, that 5, that's the horizontal asymptote. So I'm just going to go ahead and put this at 5 here. He has a horizontal asymptote at 5. Let's make that 5. All right, and then I do the xy table like we do for all the basic graphs, right? Our basic technique of solving a graph. We find the center point. How do we find the center point? Remember, we always plug in whatever will zero out the x zone, huh? So this, let me write it up here, 2 to the x plus 5, y equals 2 to the x plus 5. This is the x zone, it's just x, so it's just going to be 0, huh? If that was something like x plus 1, then I would plug in -1, wouldn't I? It's whatever would make x's little world become 0. Remember, that's how we always find the center point for all these graphs. So in this case, x's little world is the power world, and it's just simply x. That'll change in a minute. But so our first plug-in will be 0. Okay, now what do we get when we plug in 0? 2 to the 0 plus 5. What is 2 to the 0? Anything to the 0 power is? 1, huh? Good, yeah. 1 plus 5, 6. So it's over 0 up 6. So that's right here. That's just above the 5, huh? Remember the asymptote line's at 5. So over 0 up 6 is just one dot above that. That will almost always be the case. That the first center dot is 1 unit above, almost always above, sometimes below, but almost always 1 above or below the horizontal asymptote. Almost always, not quite always. How do we find the other point? We've got the center point. How do we find the other? We always add 1, huh? Remember for all the graphs, remember how we do that? The center point is first, and then you add 1 to find the other point. Plug in that 2 to the 1 plus 5. That's just 2 plus 5, 7. Over 1 up 7. Kind of running out of room here. Over 1 up 7 would be like up here, huh? And this horizontal asymptote line's at 5, and this is over 0 up 6. All right. Is that making sense so far? Everybody see those 2 dots? And now we need to connect those 2 dots and come down flat. In fact, I can make this a little longer if that's helpful. Like that. Yeah, exponential graphs will always have one side where they rocket up or down and the other side where they flatten out according to the horizontal asymptote line. So once I had these 2 dots, and I knew it was going up to the right, that must be the rocket up side, and the left side must be the flat. Sometimes they rocket up to the left and flatten to the right. Sometimes they rocket down to the right. and flatten on the left. Sometimes they rocket down to the left and flatten on the right. But they will always have one side that's a flat side, flattening out, and one side that's a rocketing up or down, always. So once you see where it's going up, you go, oh yeah, boom, that's the upside, and the other side must be the flattening along the horizontal asymptote. And there's the graph. So we got our two dots like normal, right? Center point, whatever zeroes out the x zone, and add 1 to that. So get you 2 points. But remember, the first step, what's different about graphing exponentials is we started with the asymptote, didn't we? Does everybody catch that? That's the first step. So that's different. We don't normally start with an asymptote, huh? Questions on that one? Are we good? All right, let's try this one. So we have y equals 4 to the x minus 1 minus 1. All right, let me give you a second. Yeah, so you don't start with table making for exponential. Oh, by the way, how will you recognize? You know, a lot of the hard thing about a math test next Thursday or any math test is recognition, huh? Everything can kind of just like look the same. You know, we do so many different things, and you get to the exam, and you're like, it all looks alike. You know, I don't know which one to do. How are you going to recognize? What is the mark of an exponential function? How do you know this is exponential? X is in the power zone, right? I mean, maybe that seems silly to say, but I just want to be really clear on that, right? X is in the exponent zone. Not just that it has powers, right? It's not just that it's like x squared. That's not exponential. That's got powers, but it doesn't have x in the power zone. Everybody see that difference? So when x is in power, so I'll just write x in power, we go exponential. So on the test next Thursday, I can't talk and write. Exponential. Okay, x in power, you go, it's exponential. And the first step is the horizontal asymptote, which is that, huh? It's whatever number is added or subtracted outside of the x thing, right? Good to there. So do your horizontal asymptote. Where's the horizontal asymptote going to be then? Going to be down at -1. Like that. Down here at -1. Everybody good there? Now, take it from there. Go ahead and make your table, XY table. Find the center point. Find one other point. I'll do it up here. XY. So start with the center point. So what x, looking here, here's x's world, huh? Whatever, you know, wherever x's world is, right, you look right there, and you say, what can I plug in for x there that will make x's world become 0? Just +1, huh? So when you do that, you get y equals 4 to the 1 minus 1 minus 1. That's 4 to the 0 minus 1. And what's anything to the 0 power? 1. 1 minus 1 is 0. So over 1 up 0 right there. Over 1 up 0. There's that. Notice how that's just 1 above the horizontal asymptote line. That's almost always what's going to happen. So you should expect that when you see it, you go, yeah, I'm right on track. It's all looking good. I mean, every now and then they could do something really weird. I'll show you one of those, but pretty rare. Usually it's just 1 above or below the horizontal asymptote line. It's a good sign that we're on the right track. And then what do we do to find the other point? We always just add 1, huh? You always just add 1 to whatever your first center x value was. Just add 1, plug in 2. Kind of running out of room here. So plug in 2. What are we going to get? 4 to the 2 minus 1 minus 1. You can read all that. Like that. So what's that? 4 to the 1 minus 1. What's that? 3? So over 2 up 3. It's up like this. Over 2 up 3. Okay. So now we're prepared to graph. Remember that it always has one side where it rockets up and one side where it flattens out. So this one just looks like it's rocketing up that way, flattening out that way. Is that good? Is that making sense how to graph exponentials? So the first thing is to recognize it's exponential because x is in power. Then you grab the horizontal asymptote, the number off to the side that doesn't have an x on it, -1. Put the horizontal asymptote, plug in what zeroes out the x zone, and then add 1 to that. Put those 2 dots on there. Good? No questions? Are you sure? I feel like I'm begging you for questions. You guys are the no question group. Okay, so let's try that one. So 49 to the x, 7 to the x squared, 2401 squared. All right, so when you see all those, remember the name of the game, make the bases the same. And you want just one base on each side. So as you look at 49, 7, and 2401, what's your hunch of the smaller number you can make them all the same at base for? 7. It's got to be 7, huh? Because we know 49 is 7 squared. So I look at that 2401 and I go, hey, 2401, I bet you're a bunch of 7s. Just take out your calculator, go 7 times 7 times 7, and pretty soon you'll see a 2401 in your screen. Hopefully. Is it 7 to the 4th? So everybody good to there? I made the 49 into 7 squared and the 2401 into 7 to the 4th. And then you know from there, powers inside multiply powers outside. So that's 7 to the 2x, 7x squared, 7 to the 8, right? Good so far. Now we have to combine these into a single 7. The other side's already good. How do you combine those into a single 7? What do the 2x and the x squared do? Do they multiply or add? Add. Yeah, good. Are you clear on that? Because they each have their own 7, huh? It's not just one base power with power. That would be multiply. That's like over here. 1 7. On the right side, we just had 1 7, 2 powers. They multiply. On the left side, 2 7s. Those powers add, right? Good. All right, so that's all step 1. Right? Make the bases the same. We did. So now, step 2. And I'm totally out of room. I'll just squeeze it up here. Step 2, powers equal. So this power equals that power. So 2x plus x squared is 8. So you know the drill. Got x squared, get a 0. Jump the 8 over. I'm going to reorganize it. X squared plus 2x minus 8 is 0. 2 parenthesis factoring. X is in the front. We're looking for what multiplies to be negative 8 and what adds to be 2. What times what is 8? 4 and 2. Now, how do the signs go? Sign in the middle always goes to the bigger. Who's the bigger, 4 or 2? 4. Sign in the middle is plus. Sign on the 4 is plus. But then it's opposite when you get to the actual answers, huh? It switches signs. So the answers are actually negative 4 and positive 2. Like that. And we're done. Is that good? Questions on that one? All right. So 24, so e to the x squared equals, what is that, e to the 8x? Yeah. E to the 8x times 1 over e to the 7. So we don't care that it's e, whatever. Just make the bases the same and then set the powers equal. So you got to do something with that 1 over e to the 7th, right? And you got to make that right side become just 1e eventually. So see if you remember the power rules from algebra about all that. So what do you do when that e to the 7th is flipped down like that? What does that mean? E to the minus 7. Do you remember that? Remember negative powers flip things? It's a good little thing to remember. Negative powers, what they do is they jump to the other side, then become positive. So negative powers jump to the side, then become positive. So we get that, and then that's just 8x minus 7, e to the x squared. So that's all step 1. We've made the bases the same. Is that good on that? And then you know the drill. Just separate equation with just the powers. Step 2, just set the powers equal. Like that. We don't care about the e, whatever, it's a special number. Bases are the same. Set the powers equal. Once you've got just one base on each side, just set the powers equal. How do we solve that? Finish solving that. X squared equals 8x minus 7. What do? Just jump it over, x squared minus 8x plus 7 is 0. Factor, x is in the front. What multiplies to be 7 adds to be negative? What times what is 7? There's 7 times 1 is the only option, huh? How can those make negative 8 in the middle? Both negative, huh? Negative 7, negative 1 is negative 8 in the middle, and those multiply to be positive 7 at the back, don't they? Is that good? And so then the answers are actually opposite, plus 7, plus 1. And there we go. Is that good? Questions on that? Everybody see that? So when I jumped these guys to the other side, they changed signs, and then I factored. Sign in the middle, by the way, always does go on the bigger one, even in this case. That'll always work for you. Remember, sign in the middle goes there. It just also goes to the smaller one. But it will always go to the bigger. That's always true. Questions? All right. And stuff. Okay, so 8 to the x is 7, and they're asking me, what is 8 to the minus 2x equal? It's kind of a weird question. It's weird. It's like they don't even really want me to solve for x. They're just giving me this weird 8 to the x thing. I don't even know what x is. Never gonna. They just want me to find out not what x equals, but what 8 to the minus 2x equals. So that's weird. That means I got to take this and somehow change it to look like that, because that's what they want from me, right? They don't want x, which is weird. They just want 8 to the minus 2x. So somehow I have to take what they've given me and make it look like what they want me to make it look like. So what do I do to this guy to make him look like 8 to the minus 2x? We'll raise him to the negative 2 power. Huh. Right? Because this power will multiply that power, and it'll be that. But whatever you do to one side, you have no choice but to do the same thing to the other, right? If they were equal before and you treat them the same, they'll be equal afterwards, huh? So I raise both sides to the negative 2 powers. Everybody see why I'm doing that? Because they're forcing me to make the left side look like 8 to the minus 2x. So I said, all right, I guess I got to raise negative 2 power. When you do it on one side, you got to do it the other. So what does this become when you raise 7 to the negative 2 power? Remember what we just said negative powers do? What do they do? Negative 49, right? No, but I see that answer a lot. On to the last section. Okay, so they're giving me a graph over there, and they're saying, hey, work backwards to the exponential function. Go from the graph back to the exponential function. How do I do that? How do I go from a graph back to an exponential function? Well, if you were here on Tuesday, you did it. But you're just not thinking about it. We did it on Tuesday. What do I mean? Remember on Tuesday, we did those table ones? Remember we started this section with those XY table ones, remember? And that's what this is. That's the point. -1, what is that? An eighth? My eyes are going. I'm getting old. That's an eighth, right? And this one is 0, 1. And that one's 1, 8. That one's 2, 64. Yeah, so it's this, giving me that graph is the same thing as just giving me a table. Huh? Those dots are just x, y values. Remember what we did on Tuesday? We would look here and go, what's happening to y? Is it adding the same number every time? If so, that'd be linear. Or is it multiplying the same number every time? If so, that's exponential. Remember those? So what is it? What's the y values doing? Are they adding the same number every time or multiplying the same number every time? Yeah, it's multiplying by 8 every time, isn't it? So then we go, oh, it's exponential. Of course, we already knew that. They said it was exponential, and we got the picture as exponential. Anyway, so we know it's exponential. And then remember what that means? We said it's c times b to the x, where b, what's the b? So the general format is c times b to the x. What's the b? It's that number. It's the 8. right? It's the 8. It is that number being multiplied every time. And then what's the c? What's the c? Yeah, it's the number across from the x to 0. Exactly. The c is always the number that's next to x to 0 on that. Whoops. A lot of flickering going on, huh? So there's our answer. We're done. So just do exactly what we did on those table problems. Realize that a graph is just like a table. And just do exactly what we did back on the table ones. Those were the first 5 problems in this section that we did yesterday. We probably did those after the fire alarm and the small group that came back. So it's on the YouTube video.
Does it have to say 1 times 8?
Yeah, that 1 is not needed. Huh? You can just go that way. Yeah, you're totally right, Krista.
I didn't know if we had to type in that one.
Not required. Algorithms? Are they your favorites? All right, so we're going to start assuming you know nothing about logs. Even though you had logs, the intermediate algebra. We're going to start from the ground floor and build on up. So basically what we're doing right here in the beginning is we're just going to translate languages. Kind of like going one or uno, right? I'm going to say the same thing in 2 different languages. Here it's being said without a log in power language, exponential language. And they want me to change it to log language. Translate languages. So I'm going to put a log thing there and change the numbers around somehow to say the same truth in another language, in the log language. How do you do that? Well, here's the simple rule. Let me just write it down here. Oops. When you gain or lose a log, because that's what we're going to. Sometimes we're going to gain a log. This problem we're gaining the log word. What do I mean? There's no log word originally, and I'm putting one on that wasn't there. So I'm gaining a log word, right? So when you gain a log word, or when you lose one, we'll do that in a couple minutes. When you gain or lose a log, the base stays the base. The other 2 switch. So what do I mean? The base stays the base. So as you look at that 36 is 6 squared thing, who's the base? The base is the 6. Base just means bottom. Like what are these called right here? What kind of boards are these called? Baseboards, right? Because they're on the bottom, right? Those ones up there are not called baseboards. This is called something else. Anyway, so base just means bottom. So when we say the base stays the base, when I write that little rule, base stays the base, I mean whatever's on the bottom continues to be on the bottom. Whatever's low down continues to be low down. So that 6 is low down. He's got something on him, right? So that means I'm going to put him low down next to the G in the log. You know how logs always have a lower down number? That's the base. That's the lower down number. So the base stays the base. The low down number continues to be a low down number. The other 2, which is the 36 and the 2, are going to switch roles. So don't get confused with left, right, or anything like that. Just switch their role. What do I mean the role? Well, 6, it's got a 2 on him. Now the 36 is going to be on him, and the 2 will go over there. They switched roles, right? It's no longer 6 to the 2, it's 6 to the 36, and the 2 went over there, and we're done. That's all they want. That's the same truth in the log language that was being said up here in the power language. So what did I do? Again, don't be confused. If you wrote it like this is okay. If that's confusing you, you could write it this way, and it's just as good. Both those are right. It doesn't matter left side, right side. That's not important. What matters is roles, right? The 6 is no longer to the 2. Now he's to the 36, whichever position you have him in. They've switched roles. The base stays the base. The other 2 switch roles. That good? All right, that's what happens when you gain a log word. We gained a log word. Right? There wasn't one there. We put one on. We gained one. Okay, so 5.3 is 9 to the x. Do the same thing. They want you to bring in a log word. I don't care if you do it on the left side, right side, whatever. Bring in a log word somewhere. And when you do, the base stays the base. The other 2 switch their roles. I'm just going to put it on the left, but you can put it on the right. Doesn't matter. Who's the base? 9, because he's the one that's got something on him, so he's the bottom. The other 2 switch. Instead of 9 to the x, it's going to be 9 to the 5.3, and the x will go over here, huh? But if that bugs you, you can put it on the right side. That's the same thing, as long as it's log base 9 of 5.3. Good on that? That makes sense? When you gain a log word or lose one, we haven't done that yet, but we've gained. Base stays base, other two switch. All right. Same thing right here. So the problem begins with a log, and they're saying, hey, we just want you to make it into an exponent thing, meaning get rid of that log. So go ahead, cross off that log, and the moment you do, the moment you gain or lose a log, we're losing one now. The next line we're going to write with no log. When you lose a log, the base stays the base, and the other two switch. So who's the base? The 8, and the other two switch. So the 8 to the 4096 is 8 to the 4, and the 4096 goes over there. Done. I assume that's true. 8 times 8 times 8 times 8 must be 4096. The log is saying, that's what I was saying all along. In my language, my weird log language, that's what I was saying. They're saying the same thing. We're just translating languages. Same truth being said in both languages. Make sense? That's the fundamental, the golden rule, if you want, of logs. Is when you gain or lose a log, base stays the base, other two switch. Okay, so log base 2 of 1. Now, this is not just to translate. Now we're actually evaluating. So we want a value, we want an answer on this one. So, right, notice there's no equal sign. And there's no third part. So throw that in. See, they're not giving me equals. So I'm just going to throw in equals x. I'm just like calling it Joe. I just gave it a name over there. Equals x, like that. Does that make sense? So it's equal to x. So the base stays the base. Oh, sorry, I'm jumping ahead. So is that good so far? So because every log is supposed to have three parts. It's supposed to have a base, a plug-in is what it technically, an argument or plug-in, and an answer, what it equals. It's supposed to have three parts. This was missing its right side. So I just go equals x, then you cross off, or erase if you're in the wrong setting. You cross off the log, right? You do that, lose log, and what happens when you do? The base stays the base. The 2's the base, right? The other two switch. So the 2 to the 1, it's 2 to the x equals 1. Everybody said, let me show you a common mistake I often see. Some of the students will do this and they'll put the x like there instead of in the power zone. Do you know what word my little phrases, they're often goofy and stuff, but they are carefully crafted that if you're really following the words, you'll do the right thing. What words in my little saying are they ignoring when they do that? The base stays the base. He's not a base like that. He's got anything on him. He's a multiplier now, right? So hear those words. The base stays the base. That's I'm trying to get you over that hump by saying those words. He's got to be a base, right? So I hope you won't make that mistake. Now he's a base, right? So the x was the power. 2's got to continue to be a base. The base stays the base. Other two switch. Anyway, what's the answer to x now? Can you tell by looking? No. What is it? 0. Yeah, anything to 0 power is 1, huh? Now that's how you solve it by hand. Let me also show you by calculator. Even though they say without using a calculator, calculator's fine with me. So now let's show by calculator. So by calculator, do you guys have your calculator? Look at your calculator, either the graphing or the regular. You have 2 log buttons. Have you ever noticed that? Other in your, what's it called, your algebra class? 2 log buttons, right? You have a regular log and an ln. What does the ln stand for? Natural log, it's backwards, right? Logarithmic natural, it's for a lot of algebra was done by French people, so it's a French word. The adjective comes after the noun, blah, 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 whatever. Natural log. So anyway, they don't show bases there. They don't show bases. Every log has a base. So those 2 must have understood bases. Kind of like when I write a root and I don't show anything in the hook, what's really in the hook? 2, right? Same kind of thing with these logs. They have understood bases. What's the log on what's the base on the log word here? It's 10. Do you know that one? It means base 10. It's called the common log. It's the one they use most commonly. So after a while, they just said, look, if I don't write anything, I mean the 10. And then ln, he has a base that's different. What's his base? Understood. It's e. Yeah. Remember, e is that number we found naturally in different things. So yeah. Those are the understood bases for those 2. So those are the 2 logs you can do with your calculator. So if somebody asked you, what's the log base 10 of 2? you could do it. You would just hit log of 2, and it means base 10 automatically, and you could get an answer for that. Or somebody asked you, what's the natural log of 2? You got a button for that. You can do that. But what if somebody asks you, what's the log base 2 of 1, which is our question? You don't have a log base 2 button. You might. Some of the newer calculators can do whatever base you want. But most of the older ones, you can't. You don't have a log base 2 button. So how are you, right? You guys with me? Am I loose yet? We have 2 buttons, log base 10 and log base 80. And we don't have any other. So how do we do any other log base other than 10 or e? There's a lot of other numbers that can be bases. I mean, how do we do those? Well, there's a special rule, and here it is. The rule is you make it into 2 logs, and the high goes high and the low goes low, and it'll work fine. So the high goes high, and the base one goes to the bottom. And then just hit the buttons on your calculator. You make that 1 log, base 2, into 2 logs in a fraction. Now, I haven't proven that. I just said it so. Don't got time for that. Be glad to show you after class. There's a little proof that that's true, and it'll always true. It's called the change of base formula. Why is that? Because now these are base 10 logs, aren't they? We just changed from base 2 to 2 base 10 logs. Anyway, you don't need to worry about all that. Just hit the buttons on your calculator. Log 1 divided by log 2, and you'll get 0 because the top is 0, which we already knew was the answer because of our by hand work. Question?
If you get math on TI 84,
You can get whatever base you want, huh? Yeah, you sure can. Hit math, and you can do that kind of thing. Now, this question might be on part 1 of the exam Thursday. I don't exactly remember. I think it might be. I can't remember for sure. Anyway, if it's on part 1, you're not going to have your graphing calculator. So make sure you can do this on your scientific calculator. And definitely bring your scientific calculator with you for part 1 for Thursday. Remember the test, exam 2 will be just like exam 1. We're going to give you part 1, where you don't have a graphing calculator, but you can use a scientific. And then part 2, the sum, will give you part 2, where you can use your graphing calculator, right? So make sure you can do this with your scientific in case it's on there. I don't remember. So is it part 2? Yeah. So anyway, answer 0. Funny base one. All right. So we have log base 1/3 of 729. So you can do it by calculator or by hand. I'm just going to show by calc. So when you do by calculator, you make it into 2 logs. And how do you do it? The higher one goes high, the lower one goes low. Like that. Is it like -6?
Yep.
Good? You getting that? You guys able to get that in your calculator?
Genius.
I'm just doing the by hand thing. You got to flip the 3 because I'm just thinking equals x 1/3 to the x is 729. So you got to flip that 3. So I think it's got to be negative because you got to flip that to be a 3, and then 9 times 9 is 81. So it's anyway, yeah, just it's higher than that. So I was kind of guessing it was 6 or 7 or something like that. So just use calculator. Calculator's fine. Is that good? Does that make sense? We good? I always lose when I race the clock. It's the story of my life. All right, f is log base 4 x to the 8. All right, so they're asking us domain. Domain. So what we're going to do, what we do for domain is we have, you guys already know, for domain, what do we already know about, like, doing domain? What do we do, like if there's a denominator, for example, for domain? Not equal to 0 and solve, right? That you know already, right? And second, what if you have the root, you have something inside of a square root? What do you always do with the inside of a square root for a domain question? Right, this you know, right? Don't be shy. Please tell me. What do we do when you have inside a square root? Domain greater than or equal to 0, right? Can't be negative, right? You can't have negative in a root because square root of negative number is imaginary, right? Remember those? So those are things we commonly do, right? We're going to add a third now to this list. If you have the log and you have something inside the log, basically the inside of a log is got to be greater than 0. No, not greater than or equal. It cannot be 0, it's not 0, and it's not negative. It cannot be 0, and it cannot be negative. You guys have your calculator? You can test that out. Take the log of a negative number, it'll go air. Or log of 0, air. Either one. You can't have 0 and you can't have negative inside of any log. It just doesn't work. It's not in the domain. It's like putting knives in the toaster or tin foil in the microwave. You're not supposed to do it, right? Things don't work well that way, right? So, so we have 3, and there will be no more. That's it for the whole course, all those 3. If you got those down, you got all our domain issues for the whole course. It's just those 3 domain issues. Denominators can't be 0. Remember, that's the big no-no. That's an error. Inside of a root can't be negative. It's got to be greater than or, but it can be 0, huh? Square root of 0 is 0. That's fine. But you can't put negative because that's an error. That's imaginary. And the inside of a log can't be 0 and can't be negative. It's got to be greater than 0. So when they give us this question, say, what's the domain of this log? We grab the inside. Who's the inside? You look at this. Who's the inside? It's this. See, the 4 is the base. He's not the inside. So all the rest is the inside. And we say, hey, inside, you've got to be greater than 0. That makes sense? Inside. Not greater than or equal to 0, but greater than 0. Can't be equal to 0. All right, so how do we solve that? What x values, to the 8th power are greater than 0? What numbers to the 8th power are greater than 0? Almost everything. There's only one thing that's not greater than 0. 0 itself. Right? So in other words, you can be anything, but you can't be 0 itself. That basically says, doesn't it? Right? You can be any negative number, any positive number, because the 8th power will make it positive and bigger than 0, right? But you can't be 0 itself. So the answer to that one is you can't have 0 itself. Everybody see how this led to that? That makes sense? All right. All right, try that one. That one's going to be similar, slight different, not much. So let's try that one. Same kind of thing. So x is in power, so it's exponential. So the exam's not multiple choice, right? It won't be. You have to graph it just regular. So what's the first? What's always the first step? Define the horizontal asymptote, huh? We have, what is it? Y equals 2 times 1/4 to the x. So what is the horizontal asymptote? Is it that 2? No, it's 0. It's plus 0. It's a number added or subtracted off to the side, not a number multiplied. Yeah, so the first step is horizontal asymptote is y equals 0. In other words, it's just the flat axis. That is our horizontal asymptote. That makes sense because there was no number out there. So it's 0. So the horizontal asymptote is whatever number is added or subtracted off to the side, in this case, 0. The 2 is not the horizontal asymptote. Why not? Because that's multiplied. That 2 is multiplied. What that is, I don't know if you're, I have a bad memory, so I don't like lots of facts to memorize. I like steps, but if you have a really good memory, I can just tell you what that 2 is if that would help you. The 2 is actually tells you how far off of the horizontal asymptote the first center dot will be. It's going to be 2 off of that line this time. Anyway, I don't know if you want. I wouldn't like that. I'd be like, whatever, just show me the steps. So the steps are the same as usual. You don't have to memorize what I just said. Just do the steps, you'll find that to be the case. So find the center point first off. Find that center point. Plug in whatever x value is needed. So what x value is needed to find the center point? 0, yeah, because x's world's right there. It's just x, huh? So just plug in 0. Y equals 2. 1/4 to the 0. Anything to the 0 power, that's 1. So 2 times 1 is just 2, huh? So the center point is over 0 up to. See how I was saying that that it's going to be 2 away? So this is a rare case. Usually, the center dot is 1 above or below the horizontal asymptote. So this is a rare case where it's 2. It's because of that 2 right there. See, normally they don't put any number multiplying in the front. So normally it's just 1. That's why it's 1 off usually. But if they put a number there, then 2, yeah, that is it. If you want to memorize that, you can just do that. All right, and then you add 1. So plug in 1. What are we going to get? 2 times 1/4 to the 1. That's 2 times 1/4. That's a half, huh? Or 0.5. I just do 0.5, a half, whatever. So over 1, up a half, about right there. Pretty good. I just went up half a unit, right? This is up 1, up 2. So I just went up half a unit like that. Is that making sense to there? Right? So we got our center dot, over 0, up 2, and then our other dot, over 1, up a half. Half a unit. I plugged in 1 here, 2 times a fourth, is a half. 2/4 for a half. Okay. Now, how do we graph that? Which way? What's it doing as you go to the right? Is it rocketing up or flattening out as you go to the right? Yeah, it's coming down. But all we need is those 2 dots. That's what's nice about this graphing method. Just need the 2 dots. Yeah, it's clearly the flattening side, so it must be rocketing on the other side, huh? Because it always has a rocket side and a flattening side for exponential graphs. It's good, making sense. Like you could do these on the test in a week. Questions? So first step's the horizontal asymptote line. Okay, so this one will be a tad trickier. So h of x equals the natural log 1 over x plus 4. Same thing, domain. Domain. All right, let me let you do the first step. So denominators can't be 0. Oh yeah, so we have a denominator, don't we? Yeah, so I could say x plus 4 does not equal 0. So x cannot equal -4. But that's only part of the issue. I didn't even think about that at first. But that's true, huh? That denominator can't be 0. No denominators can ever be 0. So we could do that first. But there's also a bigger deal with the inside of a log. Natural log is the same as regular log. It's just a different base. It's the same domain rules. Nothing's different. Inside of any log, natural log or regular log or whatever, the inside, which is that whole fraction, must be what? Greater than 0, right? The inside of any log must be greater. So we have two things. X cannot be -4 because denominators can't be 0. And then we have the whole fraction, the whole inside, must be greater than 0. Good so far? Make sense on that? It's just like the inside of the square root, basically. Except it can't be equal to 0. Makes sense? Inside log. Now, how do we solve this? How do we solve 1 over x plus 4 greater than 0? What do we do? You did it last week, or was it the week before? A week or two ago. Probably last week, early on, maybe just before. Remember we did those ones when we had fractions or things multiply with a greater than, less than? Remember that whole section where we had greater than, less than? We eventually made number lines and passed through and balance and all that. We found where it was above and below, and we said, oh, you want greater than 0, you want the above. Or less than 0, you want the below. Remember those? That's one of these. Remember that? When you have greater than 0, less than 0, that's one of those number line ones. Remember what you do with a fraction? You say, okay, numerator 0 or denominator 0. Solve each of those, put them on the number line, asymptote, greater, bounce, through, pass, in behavior, that whole thing. Remember that? So here we go. Numerator, that's just 1. That's never going to be 0. It doesn't have an x, so skip that. Denominator, that's x plus 4 equals 0. We already solved that once, -4. So put that on. That's the only spot that's going to go on the number line. Remember that from last week, or 2 weeks ago, something like that? -4. So now, -4 is actually a what? It makes the denominator 0. So what does that mean it is on the graph? Vertical asymptote, exactly. Right? -4 is a vertical, because it makes the denominator 0. Remember all that? Is it coming back? And then you want to find out, like, is the graph above here and below there, or vice versa, or above, both? You know, where's the graph? And then my answer will be the parts that are greater than 0, which means above. I just got to find out where it is above. So how do I find out if it really is up here like this, or maybe it's down? How do you figure where it is above? This means above, right? Greater than 0. It's positive, above. So how do you find out? How do you go over here and find out if it's up here or down there? Plug a number. Something to the right of -4, like -3 or -2 or -1, or how about 0? I always like 0. Plug in 0. Anything over there on the right side. Just plug in one number, right? Whatever it's doing one place, it's doing that whole side because it can't change its mind, right? There's no other x-intercepts. Remember all that conversation? So just plug in a number, like plug in 0. Where? Into the thing, the fraction. Plug in 0. What do you get? 1 over 0 plus 4, 1/4, which all I care is it's positive. I don't care what the number is. It's up here, isn't it? It's positive. What about over here, like at -5? What do? Plug it in. 1 over x plus 4. Plug in the -5. 1 over -5 plus 4. That's 1 over -1. That's negative. It's down here, isn't it? All right, what do they want? Greater than 0, above, which is there, huh? There's where it's greater than 0. That section of the number, so which is what? -4 to infinity. That's infinity off to the right there. Good. -4 to infinity. We're done. This is a parenthesis, not a solid bracket. Why? Because x cannot equal -4. You can be close to -4, but not right on. Remember all that from last week or 2 weeks ago with the number line? It's just one of those. How do you know it's one of those? Because it's greater than, less than. Any greater than, less than, with a fraction or x is multiplied is one of those. All right. Try that really quick. All right, so you guys have your calculator? ln 30 plus ln 15 over log 30 plus, it's just hit the buttons, but let me tell you this, it is easy to mess up. You need to parenthesize the top and the bottom, unless you have those newer calculators. If you have a calculator that automatically makes it look like a fraction when you're typing it in, then great. You don't need to mess with parentheses at all. Your calculator's good, it'll handle it. But if you have the older style that puts it all flat on one line, doesn't make it look like a fraction, then you need to parenthesize. Otherwise it won't know what's really the bottom and what's really the top. That make sense? Yeah?
Is that one like this on our test?
Could be, I think so. I don't exactly remember.
Would it be like the first section or the scientific calculator section?
I just don't remember. Yeah, so you want to make sure you can do it on scientific. It could be. It's fair game for either part. Because it doesn't really need a graphing calculator, is my point. In other words, you could do it with a scientific. So I could put it on part 1. You don't like my answer, I can tell. But that's the truth. So you're going to need to make sure you can do it with scientific as well. So make sure you can do this with scientific or graphing. So with scientific, you would need to go log 30 plus log 15, parenthesize that whole thing divided by, oops, this should be regular log 30 plus regular log 50. There's log and then like that, and then equals. So that's why you'd have to do it on the old cheap scientific calculators where the whole thing's flat. Even a lot of the scientific make fractions now though too. So if your calculator makes it look like a fraction, great. Then just type it in like it looks. All right, somebody got an answer? 2.303. Anybody else getting that? Yeah? Okay, good. So that looks like the answer. So make sure you can get that. If you have trouble with that, grab me after class. I'll be glad to help you. 10 seconds probably is all it'll take. Come on up. Okay, y equals natural log of x plus 3. First off, find the domain. That's easy, isn't it? Find the domain of that thing. Can you do that in part A? What is the domain? What do we do for domain of a log? Any kind of log, natural log or regular log, doesn't matter. It's almost like a square root, right? Just pretend it's a square root. What would you do if that was square root of x plus 3? You would say inside greater than or equal, but we just do greater for log because you can't be equal to 0. So we say x plus 3 greater than 0. Just pretend it's like a log, except it can't be equal. Right? So that means that's easy. I don't need to do fancy number. Why don't I have to do number line and everything for that? Well, because that's not a fraction. And that's not x squared. It's only if you have x is multiplied or divided fraction that you have to do the whole number line, bounds, pass through stuff. If it's just first power, just solve it. Make sense? Everybody see the difference? All right, so there's the domain. They want a lot more than that, though. So let's go back. We're doing the whole, these are long. These are really long. Basically, they're going to have us do a whole bunch of parts. So we already did part 1, where we found the domain, right? The domain is x is greater than -3. Then they're going to basically have us graph it. Then we're going to find the inverse function. Then we're going to graph the inverse function. They're going to have to do everything on these. There's like 6 or 7 of these, but they're so valuable to your growth and understanding of all these functions. So it'll demand a good couple hours of your time if you're quick. If you're getting them quick, it'll be a couple hours. So every now and then I feel like I need to give a straight word about math. Math takes your life, or you won't get it. I mean, really, you got to be willing to work hard to learn math and science. That's just the nature of the beast. It's like learning Chinese, right? It's not like taking a history class. And I love history. I'm listening to Winston Churchill as I drive around in my car. I listen to the history of the World War II time. I love that stuff. Very interesting about what England and Germany, where everybody was doing. I love it. If I had to do it again, I'd probably do history. I'm just saying, so I'm not putting history down. I'm just saying math is like learning Chinese. So let me just say this. We're coming up on a test in a week. You have to really work that way. You got to plan to spend, like this section especially, 3-4 hours. I did. I'm your math teacher, right? I knew it coming out of the womb, right? No, I'm not that way. I struggled with it. I don't know if you think that way of math teachers. I just popped out math. No, I put hours and hours. My wife, my sweet little wife, has a math degree. She would do all the homework problems 3 times in a math class, not just once. She would laugh at she does still laugh at my practice exam stuff. She's like, you give them a practice exam? She would do all the homework first time, and then before an exam, like Thursday's exam, she would redo every section again. All the problems in that section. She would take practice, and that's not enough practice at all. And then before the final, she'd do the entire course again, all the homework. I'm not joking. I've checked with her several times for exaggeration. She's not. My wife is straight. That's what she did. I didn't work quite that hard. But my point is, that's the deal. So if you're thinking, I can't do math, well, careful. Can you not do math, or will you not give math what it requires for mastery? That's what it requires. It's not like history, and I love history, but it's not obvious. History's pretty obvious, right? I mean, it's interesting. I love it, but it's not as like you got to keep beating your brain, right? Math, you do. All right, enough with the spiel. So these problems are going to take tons of time. If you shortcut them, you shortcut them. But if you want to go on, you want to learn calculus and be an engineer or something, you better do these. You better really do these like 7 problems until you got them. Okay, but it's hours of your life. So let's look at this one. Y equals natural log of that. How do we graph it? Now, I haven't shown you how to graph logs. Let me mention. Let's just go make the XY table like we always do for graphs. This is the 8. Remember, we had the basic 6, and then we had the exponential graph we learned today. And now, lastly, log graphs. How do we graph logs? Well, you know what we always do first to find the center point. What do we do to find the center point? Plug in what will zero out the x zone, huh? What will zero out this little x zone? -3. Plug in -3. All right. Plug in -3, get natural log of -3 plus 3, natural log of 0, and what's that? Don't be hitting those buttons on the calculator. Well, go ahead if you want to. But we've already talked about it 5 minutes ago.
Oh, that's right.
You can't put 0 or negatives in a log. It's an error. Right? Remember, you can't put 0. Go ahead and check if you want to. You can't put 0 or negative in a log. We just put 0 in a log. That's a no-no. That's a no-no. That's an error. That's super important. You know what that error is? It's our vertical asymptote. That's where your vertical asymptote is. Go ahead and put that on the graph right now. -3 vertical asymptote. So just like exponential functions have a horizontal asymptote, logarithms, which by the way are the inverses, logarithms, what are they? They're inverses of exponentials. They have a vertical asymptote. They always do where? Right where x is 0. Right where your center point is. So it's not really a point. It's actually a vertical asymptote line. So what do we do for the other point? Add 1, right? That's not adding 1. -2. And plug that in. And so what are you going to get for that? Y equals the natural log -2 plus 3. Natural log 1, which is 0. You can check it on your calculator if you want to. Back 2 up 0. There's that dot. I got 1 dot. I got 1 dot in a vertical asymptote line. Yeah, I would suggest getting another dot, would be helpful. Let's just add one again. You don't have to, you can kind of guess. Probably good to just get another dot. So I'm just add one again, because I need a second dot to know if it's going up or down or what it's doing. Well, yeah, it would be best to. So plug in the -1. What do you get when you plug in -1? Y equals natural log of -1 plus 3, natural log 2. Somebody got an answer? I don't even know what that is. Is it 0.7 or 8 or something? 6, 9. I'll just say 0.7. It's best I can graph. So back 1, here's up 1. So it's like right there. And it's not quite all the way to 1. So back 1 observe, but it's positive, exactly. Back 1 up 0.7, you know, this dot here. So what does that mean about my graph? Well, it's going to go like this. It's climbing to the right. And logs always take a dive or a climb, if they're flipped, at the vertical, right? Because you know at verticals it's either going to go up or down. And how I know which one is it's going up to the right. By the way, look how the log goes up slowly. It's a slow growth function, huh? Concave down, it's like a bowl turned down. That's the opposite of the exponential. Remember, exponentials rocket up. They're like a bowl turned up. Logs are inverses of exponentials. If you wonder, I did, like, what is a log? It's the inverse of exponential functions. So there it is. It's slow growth to the right. We've graphed it. And now they're going to, everybody got that part down? Because there's more to this question. These are super long, super valuable for your growth in all these functions. Is they're going to now ask us to find the inverse of this. So we've got y equals natural log of x plus 3. So after finding the domain and graphing, now they're going to say find the inverse. Now, we did that the other day. How do we find the inverse function of any function? Step 1, switch x and y. Yeah, it's like everything we've done comes together in these questions. Graphing, logs, exponentials, inversion, domain. It's like everything is in these questions, where they're super long and super valuable. So switch x and y. X comes over here. Y goes over there. Step 2, solve for y. I wish I had like another hour. All right. Look there. Solve for y. How am I going to take that thing and solve for y? You know what I've seen several times, and you can tell by my tone it's not right, huh? It's just divide by that natural log. Yeah. No. That's not multiply. That does not mean natural log times y plus 3. Even though there's parentheses, I know there's parentheses, but it doesn't mean times. Remember, it's a toaster. That natural log, that's plugged in. You know what it's like? It's like f of y plus 3. You know, it's plugged into the function. Natural log is a function. The parentheses are the insert slots in the toaster. It's in the log. It's not next to the log, even though visually I know it's next to the log. But you want to think that's plugged into the log. It's in there. It's not just multiplied by the log. So we can't do that. Well, what do we do? What do we do? I want to get rid of the log. I want to lose the log. Didn't we just talk about that 10 minutes ago? About how you lose a log. You don't divide. What do you do when you lose? I'm going to lose it. Here we go. Lose the log. What do you do when you lose a log? Base stays the base. The other two switch, right? Isn't that what we talked about 10 minutes ago? Whenever you gain or lose a log, that's what we have to do here. When you lose a log, a natural log or any other log, the base, can you use that on the screen? Stays the base. The other two switch, right? We know that. It's not a divide thing. It's that special golden log rule. So that's the golden rule for logs. When you lose the log, the base stays the base, the other two switch. Now, I don't see a base. I don't see a bottom number, a low down number. What's the base? E, right? Regular log word would be 10. LN word is E, naturally occurring number, E. Right? Remember, regular log, base 10, LN, base E. So there's the base. So when you lose the log, base stays the base. He'll continue to be low down. Other two swap. Instead of e to the y stuff, it'll be e to the x, and the y stuff will go over there. Does that make sense? Base stays the base. Other two switch. The x stuff and the y stuff, swap. Everybody good there? right? Base stays the base, other two switch, right? It's what we always do when we lose a log, huh? We don't divide, we have the golden log rule. When you lose a log, base stays the base, other two switch. Now, we're supposed to solve for y. What do we have left to solve for y? We're so close. Just minus the 3. So e to the x minus 3. And then they'll tell you to graph that. This is all one problem. Right? Original natural log, find the domain, graph it, find the inverse. We've got it. Now graph the inverse. So how do we graph that? Well, we've been practicing that today. We've been practicing exponentials. If I go to graph that, what's my first step? This is exponential, right? X is in the powers. And by the way, notice the inverse of the original log is an exponential. That's what I was saying. Exponentials are inverses of logs. That's what logs are. And that's what exponentials are. They're inverse functions. So how do I graph an exponential? What's my first step when x is in power? It's not because of the e. E's just a special number. I don't care about that. X is in power. That's exponential. So how do you graph exponential? What's the first step? Not the table. Horizontal asymptote, right? This right here. Horizontal asymptote at -3. So go down 3. Put your horizontal asymptote. And then you make your table. And I have no room left anywhere. I'll make my table up here, I guess. What am I going to plug in for x right here? 0. This will be the center point. When you plug in 0, that's, can you tell what that is? E to the 0 minus 3. That's 1 minus 3, -2. Okay, over 0 down 2, look at that. The dot is almost always 1 above the horizontal asymptote. Right there. 0, -2. We good? And then you add 1. Plug in 1. When you plug in 1, what do you get? Y equals e to the 1 minus 3. Use your calculator. E to the 1 minus 3 is going to be minus 0.3, I think. Something like minus 0.3. So that means over 1, down a little bit. That's all I care about. It's down a little bit. 1 down, 0.3. But it's higher than that other point was. Right? You guys getting that? E to the 1 minus 3. Isn't it like negative 0.3?
Yeah.
Yeah. Negative what?
I'm sorry, 0.28.
2/8, so rounds 0.3, right. So there it is. So look at this. Rocket. Remember, exponentials rocket on one side, flatten on the other. See that? Now let me show you this. Let's end with this. Everybody got that graph down? Everybody see what we did? We found our two dots, horizontal. Look at this. What if I go back and put that graph on the same graph with the last one? Or I could just bring the last one forward. How about that? Let me look at the last one. See this? Here's the last one. Remember the natural log right here? Right, that we just graphed? Vertical asymptote at -3 and then that whole thing. Let's go put that on the other graph with our other one. So -3. Okay. Now, we have E. We haven't talked much about E. E is just a special number. E's nothing, no big deal. I'm not going to do anything different. E's just 2 point something. Like pi is a special number, right? Pi's 3 point whatever, right? 3.14 whatever. E is 2.718 blah, 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 whatever. E is just a special number. In calculus, you'll see what it's for, right? Anybody know what pi is for? I won't use up too much time with this. Real quick. What's pi? Do you guys know that pi, if you go around a circle, that's 2 pi r. If you go across the middle of the circle, halfway is r. So all the way across is 2r. If you divide those, you see you get pi. Pi is measure around a circle, measure across a circle, divide those two. That's what pi is. They discovered it, ancient Egypt, you can read back, right? And back, that's when I think the first historically started showing up. They were measuring around circles, like tree trunks and rocks, things that were circular. They'd measure around them, they'd measure across them, they'd divide those numbers, they kept getting things close to 3.14, depending on how accurate their measurements were. And it didn't matter what size the circle was. Little bitty tiny circles, really, really big circles. Measure around it, measure across it, divide the numbers, 3.14. All the time. Well, it turns out, yeah, exactly. Circumference divided by diameter, 2r, is pi. It's that constant. It's just part of how circles are made, right? It's part of the warp and the woof of the way things work, right? So in the same way, E is a number like that. I won't go into the details. In calculus, you'll get more into what is E? Well, it's a number we discovered, kind of like pi, that is, it's actually the perfect number to make a derivative itself. Anyway, enough said. And continuous compounded interest. Anyway, There's a couple real life situations where E just popped up. So for now, all we need to know is E is a special number. It's a 2-something special number. Don't worry about it. Just do what you would normally do with any number. So, all right, we have y equals, looked like a 8 for a minute, 6 plus E to the minus x over 2. So when I see that on the exam next Thursday, if there's an E one, I would say, okay, it's exponential because x is in power, right? Not because of the E. Because some people think, oh, E means exponential. It's not the E, it's the x in the power that makes it exponential. Okay, so go ahead and graph it from there. And just use your calculator when you go to make the table for the E stuff. So I'll let you do work, I'll run through. So yeah, so the first thing is the asymptote, which is up at 6. 1, 2, 3, 4, 5, 6. So that's going to be our horizontal asymptote. So we always do that first. Okay, and then we make the xy table, and the center point is whatever will zero out x's world. That's just 0. So what do you get? Y equals 6 plus e to the 0. I mean, negative 0 over 2, but that's just 0, huh? 6 plus e to the 0. That's 6 plus 1. That's 7. So over 0 up 7. So that's right here. Like that. Now, what do? You add 1, huh? We always just add 1. Kind of scribbly there. Always just add 1. Plug in 1. Use your calculator. So 6 plus e to the minus 1 over 2. You can just type that in your calculator. You can use negative 0.5. That's easier. Anyway, I have no idea what that is. Is it 6 point? Oh, thank you. 6.6? So just one decimal place. It's just for you. It's just whatever helps you to graph. So I don't want any more accuracy than just one decimal place. So over 1 up 6.6. It's this is 7, so it's lower than 7, huh? You guys with me on that? It's over 6 up 6.6. So my point is it's coming down to the right, isn't it? And it must be rocketing to the left. See how I came up with that? Because the one to the right was slightly lower. Not much, but 6.6 is a little lower than 7. So that made me know it's coming down to the right. So it must be flattening to the right and rocketing to the left. Is that good? Is that okay? You guys okay with the calculator? If you have any trouble with the calculator, grab me after class. Just 10 seconds. Get back going. So I'll just type it in there. No questions? All right. I don't know if we can finish in 10. Let's finish the section in 10 and then give an hour to that one. All right. So 4 to the minus x is 16. So, yeah, that's tricky. So here's what you do. This is called, we're changing gears. Now graphs are over. So that was graph and exponentials. Now we're going to do exponential equations. We're going to solve them. Exponential equations. So step 1 is you have to make the bases the same. Step 2 is then you set the powers equal and solve. So again, it's like 6, 7, 8 of these problems where we have this. So, all right, so this is an exponential equation. Why? Because x is in the power zone. That means exponential. Okay, what do? Step 1 is you make the bases the same. You make 16 into 4 squared. It's still 16, but now the bases are the same, huh? So I haven't changed anything. It's still 16, but I've made the bases match, right? You see what I did there? So that's step 1. If you have an exponential equation, you have x up in the power zone. Step 1 is to make the two bases the same without changing anything. And then step 2, once you have made the bases the same, like we have here, you know those powers have to be equal. Why? Because if 4 to something is equaling 4 to something else, the powers couldn't be different. Or 4 to one of them wouldn't equal 4 to the other if the powers were different, right? The powers must be the same. Otherwise, 4 to one of them wouldn't equal 4 to the other if they were different. So the powers have to be equal. How do you solve this then? Just divide by -1. So x is -2. And we did it. Now, you might have been able just to guess at that answer. You can see it's right, huh? If you let x be -2, that'll be 4 to the -2. In other words, 4 squared, 16, yeah. probably could have just guessed at that instead of all this fancy, we'll need those steps in a minute, they'll get harder. But yeah, we can see that's true, huh? If you plug in -2 there, that's certainly gonna make it work, isn't it? Because the negative already in the equation hits the -2, makes it +2, 4 squared is 16. That's correct. So you see the steps? Step 1, make the bases the same. Step 2, then just set the powers equal. And you can solve. All right, let's see. This will be just to use the calculator one. So they have 2/5 to the x is 8/125. Yeah, basically I would just take my calculator out and just go, all right, how many 2's? 2 times 2 times 2 on the top. I would just go, 2 times 2 times 2, 3 2's. How many 5's? 5 times 5 times 3 5's. If you multiply your calculators, you go, oh, so x is just 3. Yeah, done. Right? I'm not going to do some fancy technique for that one. I would just, just do that. Good? Is that okay? It's just third power for the top and the bottom, the whole fraction. All right. Okay, try that one. 2 to the 5x plus 1 is 4. So go ahead and go through the 2 steps. X is in the power zone, right? So, so you want to recognize on the test Thursday, you want to recognize, okay, X is in the power zone. So you think, okay, make the bases the same. Make the bases the same. Without changing anything. Is that good? Bases are the same. And then step 2, once the bases are the same, what can we do? Yeah, those powers have to be equal. Why? Well, because if 2 to one of them is equaling 2 to the other, the powers couldn't be different, or 2 to one of them wouldn't equal 2 to the other. The powers have to be equal now, don't they? So then you just solve that. Subtract 1, 5x is 1, divided by 5. Oops, it's a funny looking fact. So x has got to be 1/5. That was step 2, powers equal. We're done. 1/5. Does that make sense? Questions on that one? Make the bases the same, set the powers equal. I don't know if it occurs to you, what if that was a 3? Or 5, or 6, or 7. 8 would work. 8's 2 to the 3rd. Or a 9, or a 10, or 11, or 12. Or 3.2, or 7.6. Do you realize this is a hokey method we're using? It's hokey. I know that. I like that word. We don't use that word much anymore. It's a method that's not really going to work in any real world. It's just going to work for these little contrived problems. Do you realize they're making problems purposely nice that will work out with our little power plan? A little power plan's not going to work if it's not a perfect little number that can be 2 to some power, like 4 or 8 or 16. What if it's something other than those? Yeah, we'll talk about it. You got to do something else. But just know, this is a little hokey right now. So here's another one they've made purposely just right so we can work it out. So when you look at that, you should probably think right away, 625, I bet that's a bunch of 5s, and take out your calculator and go 5 times 5 times 5, and just keep track. And pretty soon you'll get a 625 on your screen, because they didn't make it 624. They purposely made it a bunch of 5s. So see if you can handle it from there. So find out how many 5s that is, and make the bases the same.
What would be
5 and 4 could be 6, 2, 5. What would it be? 5
squared?
Yeah.
Is it 5 to the 4th?
Yeah.
5 to the 4th, yeah. So it's 5x squared is 5 to the 4th. And that's 5 to the 4th to the x. Good so far. Just use your calculator on that.
Oh.
Okay. And then these guys multiply. And maybe you just jumped right to here. That's fine. If you just wrote it like that, you're right. That's crazy. You don't have to do that in between thing. You don't want to. Everybody good to there? That's step 1. Step 1, base is the same. Is that okay so far? Because the x power is there, and the 625 is 5 to the 4th, is 5 to the 4x. So bases are the same. Now you know what to do from here, right? Once you got the bases the same, we can set the powers equal, right? They have to be, because if 5 to one of them is equaling 5 to the other, the powers couldn't be different, or they wouldn't be coming out equal. So now, just grab the powers. Step 2, powers equal. So how do we solve that now? So everybody good to there? Everybody good with how we got to there? Made the bases the same. Set the powers equal, right? X squared must equal 4x, or 5 to one of them wouldn't equal 5 to the other if they were different, right? These have to be equal. So now how do we solve that? Are you comfortable with solving x squareds with the equals? You want to get to the point where you're really, really comfortable. Those come up a ton throughout the rest of the course, calculus all the time. So when you see x squared with an equal sign, what do you do first? You might not know it exactly this way, but I think it'll be helpful if you think this way. Get a 0. You want to get a 0 first, and then step 2, factor. You're probably just thinking factor, and you're right. That's the basic plan. Jump that over, x squared minus 4x is 0. Get a 0 first. So whenever you see x squared with an equal sign, you just want to know automatic. You want to know this just like a knee-jerk reaction. Somebody wakes you up in the middle of the night, x squared equal sign, get a 0. You want to just, you want to know it that well because it comes up all the time. Then factor, how do we factor x squared minus 4x? It's not 3 terms, so it's not 2 parentheses, is it? It's just take out what's in common, just an x, right? You know the difference, right? Because in a minute we'll have the 3 terms, and that's where we do the 2 parentheses, right, for the factor. And then each of those is 0, so x is just 0, or x is just positive 4. Right, remember it's opposite sign because positive 4 would make that 0, or 0 would make that 0.
I have a question for you.
Question, yeah.
Wait, isn't x squared x times x?
Yeah,
Okay, and isn't 4x 4 times x?
right.
Wouldn't you divide x out of each of them?
Good question. So let me go back. So our answers are 0 and 4. Before I answer that question, everybody good to there? Then I'll answer that more tricky question. So x is 0 and x is 4 are the answers to the problem. You can see it's right if you go back up here to the original. Well, I don't need to erase that. Just go back here. If you put in 0 in both cases, it does make the equation true, huh? Because anything to the 0 power is 1. I guess we should have guessed it that one, huh? And then also 4 works. If you put a 4 in, I just have to take my calculator out to see that's true. Way too big for me to be sure, but I'm sure it's right. So 0 and 4 are the answers. Now, a good question was asked. Can't we just take x squared as 4x and just basically divide both sides by x? Boom. And x squared over x is just x is 4. That's easier than all that 0 factoring stuff. It is easier, but what did we lose? We lost x equals 0. Where did x equals 0 go? Well, let me ask you this. Look at this for a second and tell me what would happen if x was 0. X was 0 here, and see this right here? Remember the big no-no in math? Never 0 in the bottom of a fraction. Remember how at the bottom of so Carissa, right? This question is a really good one. It's a more advanced question. So let me just mention it. The reason this doesn't work, doesn't give you all the answers, is because the x equals 0 would make that denominator right there 0, right? That's not allowed, and so it'll silence. It will not tell you about that answer because that would make the denominator 0, which is never allowed in math. So it won't tell you that answer. So, long story short, you should never solve equations by dividing anything with an x in it. Because whatever makes that 0, it'll never tell you about that answer. You'll lose that answer. So we never solve equations by dividing not only just x, but anything with an x in it. We never like to divide because the denominator would be 0. So that's a good question. It's a more advanced question. So that's why we do the 0 and the factoring and all that. All right. So try that one. 27 to the 2x is 9 to the x plus 1. So you know the deal. Make the bases the same. See how they're giving you nice numbers to do that? Right? They're contriving these problems so we can do this technique. Within the hour, we'll get to one where you can't do this technique. All right, make the bases the same there. All right, can I make this like 9 to the third? Like that? No, it's not 3 times 9. It wouldn't be 9 to the third, it'd be 9 times 9 times 9. That's not going to work. 27 isn't 9 times 9. What do we do? Got to make them both out of 3s. Yeah, this is a case where you've got to change both bases to a smaller base, because you can't just make one out of the other. Even though it might look like it at first, you can't really make 27 out of a bunch of 9s multiplied. So instead, you got to go, oh, 27, that's 3 to the third power, and 9, that's 3 to the second power. Does that make sense? That's what you got to do. You got to make both of them out of 3s. Now we can make the bases the same. Now, do you remember what they're going to be testing in this section is how well you remember all the power rules. Remember, it's pre-calc and calc that'll teach you algebra really, really well. So do you remember all the power rules? Like, what do powers inside and outside parentheses do? Do they multiply or do they add? They multiply. They multiply. So it's 3 to the 6x and multiply. 3 to the 2x plus 2 it distributes. So powers inside and outside parentheses multiply. That's different, by the way, than powers like this. What would those 3 to the 2 times 3 to the 5, what would those powers do? They would just add to be 3 to the 7th, huh? Because they each have their own base. So they add. But when there's just one base, 1, 3, with powers and powers, they multiply. Remember those two different sets of rules from algebra? All right, so anyway, so that's all step 1. Make the bases the same. Step 2 now. Now we'll go to step 2 and set the powers equal.
So you can technically make the powers of
Yeah, you make the powers their own equation, right? Because they have to be equal, because 3 to one of them was equaling 3 to the other. So they couldn't be different. Yeah. So subtract that 2x from both sides. So 4x is 2. Last step, divide by 4. X is a half, or 0.5, or whatever. Is that good? Questions on that? So sometimes you have to make both bases into a smaller base. You do whatever you can to make the bases the same. Okay, so 4 to the x squared minus 20 is 16 to the 4x. All right, same thing. See if you can make the bases the same there. Well, we can make both bases there. You could just do 4. You could do 2 also. Yeah, you just do 4. It'd be easy. Kind of got into that. Got to change your mode, huh?
Yeah.
It's easy to do that.
Right, that works.
Yeah, it'll work. Just a little bigger numbers, I think, along the way there. So let's see. 16 is 4 squared, right? And then you know powers inside multiply powers outside. So that'll be like that. Good. That's all step 1. Make the bases the same. And then step 2, the powers are their own equation, equal to each other. All right, make the bases the same, then the powers have to be equal. All right, so we need to solve that little x squared equation. When we see x squared with an equal sign, we get a 0, right? First step, get a 0 whenever you see x squared with an equal. So jump this 8x over. I'll put it in the middle. You know, I always jump it. Doesn't matter left side, right side. Just make sure the x squared is positive. It's just easier to factor when the front term is positive. So I just move whichever side will make the front term positive. So do you remember how to factor things like that? Want to make sure I'm helpful to review that for you, because I know that's a sticky point. Remember how to factor? So it's 2 parentheses, right? Because we have 3 terms this time. It's not just a 1 parenthesis. Take out what's in common. It's 2 parentheses. And you're looking for 2 numbers that, remember, they multiply to be the back number and they add to be the middle. Remember how that works? What times what? What multiplies to be 20?
2 times 2.
2 and 10, 4 and 5. How do you know which one you want? Well, they got to add to be the 8. So you want the 2 and the 10, or 10 and 2, whatever. Whatever order doesn't matter, but signs do matter, huh? How do you know which one gets the plus and which one gets the minus? Yeah, whatever sign is in the middle always goes to the bigger. You aware of that rule? Right, so who's bigger, 2 or 10? 10. So the sign in the middle is negative, the bigger gets that sign. So again, the sign in the middle always goes to the bigger, right? Because negative 10 plus 2 is negative 8, isn't it? Multiplies to be negative 20. Anyway, you know the answers now. It's just opposite, huh? So minus should be minus 2, huh? And plus 10. That's off the screen. Minus 2 and plus 10. There we go. Is that good to there? Questions on that? No questions? All right. So that